When we talk about carbon removal technologies, biochar is one of the more compelling options. Why? Because not only does it provide long-term carbon sequestration, but it also offers multiple environmental benefits. Let me take you on a deeper dive into this technology and how it can help us combat climate change. First, what is biochar? Simply put, it's a carbon-rich substance made from organic materials such as agricultural waste, wood, or crop residues by thermal cracking at high temperatures in a low-oxygen environment. The process may sound technical, but it essentially locks up the carbon in the organic material so that it becomes a stabilized solid, rather than being released into the atmosphere as carbon dioxide or methane. The advantage of this is that the carbon can be stabilized in the soil for hundreds or even thousands of years, helping us to permanently sequester it and reduce greenhouse gas emissions. According to the latest statistics, 87% of carbon offsets in the global voluntary carbon market currently come from biochar. This means that more and more people are adopting this technology because it is not only effective, but also offers other benefits, especially in agriculture and soil management. So what does the process of making biochar look like? Simply put, the organic material is thermally cracked at temperatures ranging from 350 degrees Celsius to 700 degrees Celsius. During this process, the carbon in the material is locked in a stable structure. This structure is very difficult for microorganisms to break down, which is why biochar can remain stable in the soil for a long time. This form of carbon sequestration is currently one of the most effective means of combating climate change, as it not only reduces carbon dioxide in the atmosphere, but also improves soil health. It is worth noting that biochar technology has reached a very high level of technological maturity, reaching TRL 8 to 9, which means that it has been tested in multiple stages and is ready for widespread commercial and industrial applications. In fact, hundreds of biochar production facilities are already in operation worldwide, demonstrating that this technology is highly viable in the marketplace. In addition to carbon sequestration, biochar has many environmental benefits. Its porous structure improves soil water retention, enhances nutrient retention, and promotes microbial activity, all of which are of great benefit to agriculture and ecosystems. Particularly in the face of increased climate change, agriculture is facing extreme weather challenges, and biochar can help crops become more resilient to extreme weather conditions such as drought or excessive rainfall. Let's talk about the carbon removal mechanism of biochar. One of its biggest advantages is its long-term durability. Biochar, when processed at high temperatures, is virtually immune to microbial decomposition. So when we add it to the soil, its carbon can be stabilized for hundreds to thousands of years without returning to the atmosphere. Scientific experiments and archaeological studies have confirmed that biochar maintains its structure and function over long periods of time, making it a very effective long-term carbon sequestration technology. According to the latest research, the annual carbon release rate of biochar is only about 0.0018%, which means its average retention time is over 550 years. This stability makes it a cost-effective method of natural carbon removal when compared to traditional geologic carbon sequestration. Another great feature of biochar is that it is not only a passive carbon store, but also has a positive impact on the soil's carbon cycle. Biochar's porous structure attracts water and nutrients, which helps plants grow and promotes microbial activity in the soil, which in turn increases the carbon sequestration capacity of the entire ecosystem. Finally, let's talk about the potential of biochar for global carbon removal. Current research and modeling predicts that biochar could remove hundreds of millions of tons of carbon dioxide equivalent per year. In Europe, for example, the biochar industry could remove 6 million tons of carbon dioxide per year by 2030, and by 2040, that number could grow to 100 million tons. These figures tell us that biochar technology is not only feasible, but also has great potential. With the development of the carbon trading market, producers of biochar can convert carbon removal into carbon rights and further participate in the global carbon trading market, which is of far-reaching significance in promoting the transformation of green economy. In conclusion, biochar is a technology that combines long-term carbon sequestration environmental benefits, and economic potential, and it is providing a solution for global carbon removal and sustainable development. We hope that through this information, you will better understand the value of biochar and find more opportunities and possibilities in addressing climate change.